Greetings, fellow developers. Also, it is a tooltip we are developing in this tutorial. You will be surprised to know that such tutorial, done right, adopt many React and general programming concepts, such as React cloneElement, React portals, React useRef for mutable object, reducing problem with divide and conquer strategy, and recursive functions. Get ready for a wild ride in React and JavaScript programming. Let's get started now. Now, let's get started here in building this tooltip. First, I will create a component called tooltip. I'll place it in the UI folder. So here, which will be a functional component. Of course, it needs a text prop, and we'll receive the other prop in the, let's name it props. Now, this will return the children, which we'll get it by destructuring the props object. I will export the component. Now, the idea for this tooltip component is to create a tooltip that is placed outside of our application container at the bottom of the body. In able to do this in React, we need to rely on the portal class. Portals allow us to place a React component anywhere in the DOM document. In our case, we want to place the tooltip element at the end of the body element. Now, in order to use the portal class of React, first we need to create a new element that return this portal as a React element. So here I'll create a new component. I'll name it portal.js. We'll need first to import React DOM from React DOM, and we'll create the functional component portal with the props. Now we'll return the React DOM.create portal, which is a function that allow us to place an element inside any DOM element that we specify here as a parameter. So the first parameter will be the React element, which here is the props.children, and the second parameter will be the DOM element. We can retrieve a DOM element using the get element by ID, or here in our case we need to specify the body because we need to append the created element here, the tooltip element, in the body. So I'll specify the document.body. Then at the end I'll export the component. Now in my tooltip I'll import the portal and I'll use it as a component here, giving it my tooltip element that I will create now with a span, and put inside of it the provided text by the user. So now let's test this component. So in my home.js, I need to import the tooltip, but before doing that, I want to export the tooltip from the index.js general file in my UI folder. So here I'll add tooltip. So first here I'll import the tooltip and export it with the other object. This way I can import both tooltip and the button element from my UI folder. I will wrap a button with the tooltip. So first I'll create the button, which will contain a getting started label. Then I wrap this button with the tooltip. Now the tooltip need a text which is required. Here it seems I made a mistake. It needs to be with all capital letters for the DOM. So now here in my browser, as you can see, this is the button. Of course, now the tooltip won't work, but if I inspect my page at the end of the page, at the end of the body element, I can see that there is a span with lorem ipsum. So this is our tooltip generated outside of our application. Now the next thing I need to do is to add the mouse event to the getting started button. So we need to add a mouse over and a mouse out to show and hide the tooltip. So here I have the children, which is the button here, or any element that we specify, that we wrap with the tooltip component. Now, for this element, the children, I want to add the toEvent. To be able to do this, I can rely on React cloneElement. This function API of React allow me to add props to an element by cloning it. The cloned element will be identical to the original element. We are just adding two new behavior, the mouse over and mouse out. So we'll import first React, and we'll use here the React.cloneElement. We'll provide it as the first parameter, the children. Then we provide any additional props that we need to add or to append to the element current props. So here we need the on mouse over, which will be a function. We'll name it handle m for mouse over. Then we'll need on mouse out to have the function handle m out. Next, we'll create these two functions. These two functions need to set a state that is responsible in showing or hiding the tooltip. So we'll create that state. First, we'll import the use state hook from React, and we'll create here a new state. We call the state show and set show. So constant show set show, which will be equal to use state. By default, it will be 0. 0 mean the tooltip is hidden. Now I will create the function which will change the set show to 1 and the handle mouse out, which will set again the show to 0. So now we'll rely on the show state to whether show or hide the tooltip. I need to set the opacity of the tooltip to 0 or 1, depend on the show. So I'll add to it some style. First, I'll import my styled component library, and I'll create a component called styled tooltip. I'll set the position to fixed. The top and button will be now some value, so we can be able to see it on the screen. We'll later work on the positioning of the tooltip. We'll adjust the font to be a small size, and the weight will be bold, and we'll add some tiny letter spacing. The background color will be a transparent black for now. The text color will be white, and some styles for to disable the pointer events, so it won't have any interaction with the mouse or keyboard. Plus, we're adding padding to the top button left right, then a border radius of 4 pixels. The Z index will be the highest, so it will not be masked by any component on the screen in our application. The display will be inline block, and the white space will set it to no wrap, so it won't wrap the text unless the user specify using an HTML element like breakline BR. Now for the opacity, which we want to control, depend on the mouse hover of the children of this component. So we'll set opacity to P, which is the props sent to styled tooltip. Now we'll need to send the p.show. The show variable will be either 1 or 0. If it's a true, it will be 1. So we only need to return it as it is for the opacity, which also accept a 1 or 0 as values. So it worked great in our case here. All right, this is it. Oh, I made here a mistake. I put these two functions outside of the component tooltip. They need to be inside because they rely on the state to be available for them to change it. Now we'll use style tooltip component instead of our hard-coded span here. All right, and we'll pass it the prop show. All right, so let's try it in our browser. Now, if I over the getting started, I see the tooltip here. Somewhat it is positioned. Oh, I specified the button instead of the left. I wanted the left. So here is our element. Now for the positioning, we'll work on it very shortly. But now we have successfully set up the events. We have also set the placement of the tooltip properly on the DOM. All of this has been handled programmatically by our component. The user doesn't have to know about this. He only needs to wrap any element in his HTML page with the tooltip component and provide the text for the tooltip. Now let's fix the placement of the tooltip and give the user the option to choose one of 4 placement: button, top, left, and right. So here, concerning the placement, we need to specify the top and left. So we have a point of XY. So first we'll create an object here. Let's name it pose, which will be X by default 0 and Y by default 0. Now this is a mutable object. We will change it, and once we finish changing this object to adapt the position of the tooltip as desired, we'll pass it to the styled tooltip. So this will be a mutable object. It will be sent by reference to the styled tooltip. So it will change its position every time the handle mouse over function is fired. We will manipulate this object, and these X and Y will set the top and left of our component here. So we don't want to render this component each time the X or Y change. There's no need to render the component. All we need to do is change the styles of the component. So we can keep it like this in an object, but there is a better solution provided by React, which is the useRef. By importing now the useRef, we can benefit from it to set this mutable object using useRef and give it the default value in the parameter for the useRef. Now here I'll change the name to poseRef. Now what is exactly the difference? Here useRef will create a mutable object as we were creating it directly in a constant, but the difference is each time the component render, the object will stay the same. It won't rebuild the object. So this is the advantage. While if we were not using useRef, we were directly assigning the object to a constant. Every time the component render, the object will be rebuilt again. Now we have the poseRef. We will send it to our styled tooltip component as a poseRef, and in our styled tooltip styled component, we will use this poseRef to set the top and left. So here, instead of 100 pixel, I will use the p for props dot poseRef dot current dot x for the top, no dot y. Append to it the pixel. The same for the left. I'll use now the x. All right. Now if we quickly check our browser, we can see that now it is positioned to 0, 0 as we have specified here by default. Now in the handle over function, we will work on the element position. To define the element position, of course, we need a placement variable that is set by the user. This placement could be bottom, top, left, or right, and by default we'll set it to bottom. Now here, to position the element, I need to have a reference to the element brought by the tooltip, and I need a reference to the tooltip, plus I need the variable placement to define where it should be placed in relation to the child element. So first I will get a reference to the tooltip. I will name it tooltip ref, which will be equal to useRef, and we'll set it to reference the styled tooltip component by assigning the ref to tooltip ref. Now the tooltip ref contain a reference for the underlying DOM element to styled tooltip. Next, we need to have a reference to the children element. To get the reference to the child element, we can rely on the event here, which we can use the .currentTarget to get this element. Now we will create a function that will return a point, the x and y property in an object, and we assign this return point to the poseRef.current. So poseRef.current will be the result of calling a function that we will create it in just a moment. We will name it getPoint. This getPoint need as parameter, in order to be able to do its job, the children element reference, so e.currentTarget. Then we'll need the reference for the tooltip ref, and finally we need the placement that is defined by the user in order to determine the position of the tooltip. Plus we'll add a space variable that will create space between the tooltip and the element, so it won't be sticked to the children element. So now for the space, we can also allow the user to define it here by getting it in the props, and by default we'll set it to 15. Now all we have to do is create this function. It will be outside of the tooltip component, so we'll create a constant getPoint, which will receive the element, the tooltip, I'll name it as a TT, and the placement plus the space. So the main responsibility of this function is to calculate the x and y and return the final result as an object with an x. Now we'll put it as 0, and a y will, by default, it will be 0. So let's override the 0, 0 to, let's say, 50 pixel, 50 and 50, just to see it on the screen. So now if I go to my application and hover the getting started, now the placement has been changed to 50, 50. Next, we need to start with the calculation of the x and y in relation to the chosen placement by the user and in relation to the child element that is wrapped by the tooltip component. Now, in order to determine the position of the tooltip, we follow a simple calculation. So I have an illustration here to explain to you how we will do it. First, we have the button, here the black one, and we have the tooltip, here the green one. So if we want to place the tooltip from the bottom of the element, first we need to get the element bottom, then we'll add to it the space, which is default to 15 pixel. This way we get the y of the tooltip. For the x, we can easily get the left of the button. Now with the left, we can set the tooltip here, like this, adjacent to the left of the button. but what we need to do is place it at the center of the button. Now, to be able to center this tooltip, we need to add value to the left. So what is the value that we need to add that will make this button centered? We need to determine the space here, the width of the button minus the width of the tooltip, which give us here the space, the difference between the widths. So we'll get the space here and we'll divide it by 2. And we'll add it to the value of the left of the button, which will set it to Y, and will push the tooltip like this for it to be centered to the button. So let's make this happen. So here we need a point, which will be X by default 0 and the Y by default 0. We'll work on this object and we at the end will return it. Next, we need to get the top, left, right, and the bottom of the element. We can get it using the get bounding client rect function of JavaScript. So we'll create here a local constant. We'll name it bx for box, and we'll assign to it the result of get bounding client rect. It's a JavaScript function that returns the top, left, right, and bottom. Actually, I'll name the bx to lrect, so it is clearer. Now we'll create a switch on the placement. Now we'll have a case for the top and a case for the left and a case for the right, and the default will be for the button. Now we'll work on the default. To place the element at the bottom, we need to set the x to the lrect dot bottom plus, as I explained to you, we need to subtract the width of the element minus the width of the tooltip, the tt. So l dot offset width minus tt for the tooltip dot offset width divided by 2. This will give us the x we need for the tooltip to be centered in relation to the element. Now for the y, it will be lrect dot bottom plus the space, which is by default 15 pixel. All right, now this point, as we here are doing, the return value of the function getPoint is assigned to our poseRef.current. Here it needs to be .current for the tooltip ref. It's a mistake. Oh, I need to declare the pt using the keyword constant or var. Now here I made a mistake. The x, this is the y, and this is actually the x. So let me arrange them properly. All right. And let's try it in our browser. All right, this is placed properly at the bottom. Now let's create for the other values, starting with the left. Now for the left, to get the y to get the x for the tooltip, we get the right of the button. Then we subtract from it the width of the tooltip, which place it here, concerning the x-axis. Then we'll add the spacer, which add a space between the button and the tooltip. So lrect dot left plus minus the tooltip dot offset width plus the space. Now for the y, to get the y first, we get the top of the button, which will place it like this. Then we subtract from this value the difference of the width of the button minus the width of the tooltip divided by 2. So it will center it exactly. So here we'll get the lrect dot top plus the l dot offset width minus the tt dot offset width divided by 2. So if we test the left, here we'll set the placement to the left, and we need to break, of course, to stop from running the other cases, the default one. So now if we test the left, all right, so we made here a mistake. It's not the width. For the left, we need to use of course, the height. And here it is, centered perfectly. Next, we'll set the right position. Now for the right, for the X, we'll get the element rect right, then we'll add to it the offset width of the tooltip, then we'll add the space. Now for the Y, the same value as for the left. Let's give it a try. We made a mistake. Yes, sure, we made a mistake. We don't need to the width. I'm sorry, we set it to the right, which we are setting here the left of the tooltip to the right of the button, then we'll add the spacer. In that case, we don't need the width. So again, here it is, working perfectly. Now for the bottom, oh, I mean for the top. We already did the bottom here, which is the default case. For the top, which should be here, for the position X, it will be the same as the position button. We need to center it horizontally. So we'll copy the X of the bottom and we'll paste it to the, and we'll assign it to the X of the top. Now for the Y, lrect.top plus the tt offset height, or minus the tt offset height plus the space. This will put it on top of the button and add to it a space so it won't be stacked to the button. Now let's give it a try by setting the placement to top on the getting started button on the home page. So now this is working as perfect as it can be, which is good. Now we have successfully positioned the tooltip in relation to the button while giving the user 4 possible placements to choose from. Next, we have 2 additional requirements. First, the tooltip shouldn't overflow the screen. Second, the tooltip shouldn't mask the button, so it should not be on top of the button like this or this. So let's start with the first requirement. Here we have a rectangle, possibly the screen, and a point, which is the top left of the tooltip. So here is the point. So what we need is to restrict that point to a rectangular area, and here it's possibly the screen. So first thing, let's remove the button from the equation since he don't have any role in the first requirement, and work with the tooltip and the screen. So it seems like our rectangle here is the screen, but let's make sure this assumption is true by testing for the worst case scenarios and see how it holds. So worst case scenario will be if the point is on the edge like this. So if we put it here, we see that the tooltip is overflowing the screen, so it's negative, so it's not accepted here, neither here, neither here. Now here, it could be here, but we need to add some space between the tooltip and the edge of the screen, a space with default of 15 pixels, so we'll push it a 15 pixel here. So this point here is acceptable, and any other point from this side to the left side. So we'll put here a ruler. So this is, after this rule, it is a restrictive area. It is the right of the screen minus the width of the button and minus the spacer that is by default 15 pixel or whatever the user defined. Same for the button. All right, for the button we can't put the point here, it needs to be here. So we'll subtract from the bottom position of the window the height of the tooltip and minus also the spacer. So we have a new restrictive boundary here. Now for the left and top, we only need to subtract the 15 pixel. So here we have the rectangular area that represent our restriction. So let's mark it by a box, a gray box. Now after defining the rectangular area, the problem becomes easy. All we need to do is compare the coordinate x of the point to the left and right of the rectangle, and if it's outside of one of the edges, we'll set its value to that edge. So if it's here, we'll set it to the edge here. If it's from this edge, we'll set its value to this edge. Now this is concerning the X. Now for the Y, the same thing against the top and bottom. This solves the first requirement. Now for the second requirement, all right, here, let's get the button back to the equation. So here, if the button was here, if we can't push it, then we'll flip it. So it will stay on the same axis. This way we'll preserve the orientation the user intended for, which makes the most sense. Now we need to check what is the direction of the tooltip placement, whether it is on a horizontal axis, like right or left, or on a vertical axis, top or bottom. So if it's on the horizontal axis, then we check the coordinate X of the point against the left and right edges of the rectangle. So if the user choose, for example, to put it on the left, okay, the left is on the horizontal axis. In this case, we check for the X. If the X is lesser than the left of the rectangle, which is true, then we'll flip. This is the main procedure that we will follow to solve the flipping problem. The same for the horizontal axis against the top and bottom. So always when we flip, we change the placement to the opposite one. So if it's left, we'll change it to right. If it's bottom, we'll change it to top. Now it makes sense to apply the flipping first. So we check if there's a flipping case, we'll flip. Then we run the restrictive boundaries. So in other way, if we need to flip, we flip first. But if the item is still overflowing any edge of the rectangle, we'll just push it inside. And done, problem solved. After clearing things, it's easy to translate our solution into code. So let's make it happen. So first, we'll create the rectangle boundaries, the main one. So I will name it constant bdys for boundaries, which will be equal to an object that has the left, which will be equal to the space, and then the top, which also be equal to the space, the 15 pixel by default. Then we have the right, all right, which will be equal to the window width minus the tooltip width minus the space. Now here we need to get the body width to account for the scroll bar in case the page has scroll bar. By getting the document client width or the body client width, we are restricting from it the scroll bar. So document dot body dot client width minus the tooltip dot client width minus the space. For the bottom, you can use the window dot inner height, because however the document is tall, we only need to get the height of the screen here. So window dot inner height minus the same calculation here, minus now here's the height of the tooltip, then minus the space. So this is our restriction box defined and ready to be used. So first we'll check whether the element need to be flipped or not. Here we'll add an if with a couple of conditions. So if the position or the placement, if we name it placement, is equal to left, or the placement is equal to right, then here in this case we're talking about the horizontal axis, and then we need to check the point dot x. So we need to check the x if it's lesser than the bdy, the main box restriction, the bdy dot left, or if it's larger than bdys dot right. This is a case where we have a flip. The other case is for the vertical axis, if the placement is top or bottom. Now we check for the y, if the y is lesser than the body dot top, or the y is larger than the body dot bottom. This is also a flip case we have here. what we'll do here is call again the function. So we'll call the get point again with the same parameters, but instead of the current placement, so we'll flip the placement. Now here, as you can see, we are working a lot with placement here. Now we are checking if it's placed horizontally and vertically, and now we need to negate the placement. What I will do is create an object to handle this operation. So at the top here, I will create an object called position, which will be equal to a function. We send this function the position as p, all right, and it will return directly an object. Now this object has some property, a current property, which will be set to p, so you can get the current defined position. Then we have another property that will negate the current p. So here we'll add some ifs. So we check if this dot current is equal to left, we return right. So this function will return the negative of the current position. If it's right, it will return the left. Now if it's top, it will return the bottom, and if it's bottom, it will return the top. This will allow us to easily negate a position. Next, we'll add a function is horizontal, which will return true if this dot current is equal to left, or this dot current is equal to right. Another one, which we'll call it is vertical, which will return true if it's top or bottom. Right now we can use this position to help us make the code more readable. So here we can create the object. We can create a constant. We'll name it pose, which will be equal to position with a parameter of the position of the placement. Now we can use here the pose dot current to get the current position and switch against it. Now here to check horizontally, we'll use pose dot horizontal, which is a function, and below we'll use for the vertical pose dot is vertical. Now here to negate, we use pose dot negate, which will return the opposite placement as a string. All right, this will rerun the function now with a new placement, the opposite placement, and will regenerate the pose object with the new placement. Now the get point, if the check on the next iteration pass, so it will return the point. All right, here it will return the point, so we need to get the point and assign it to our current point. All right, this is how recursivity works. Always when you're working with a recursive function, you need to have a condition that give the recursive function a way to stop. Here in our case, after flipping the placement of the tooltip, it will iterate one more time, and most probably this will be enough. Now if it's not enough, we will add a condition to stop this function at the third iteration. This will do it next, but now we will check if this is working as expected. All right, we have the PT, it is constant, so we need to make it into not a constant, a normal variable. So let's go to our browser and give it a try. First, I'll make sure the placement is, let's say, bottom. So here in my browser, first, everything is working as expected. Now, if there's no space at the bottom, currently nothing is happening for some reason. Let me verify our code. First, while checking the code, I noticed here it needs to be positive. Oh, here, and also I made a mistake. It need to be and we need to combine both of the each condition. So here it need to be or. All right. So either this or this. We have a flip case. Now if I go to my browser, and here if there is no space at the bottom and the position is placed by the user to be bottom, it will flip to the top. All right. If not, it will show at the bottom as expected, else it will show at the top. All right. Now to test left and right, what we will do, we will add here tooltips for our menu. So if I go now to my menu, to the nav link, I can quickly here wrap it in a tooltip and add the text to the label of the link, and I can position it to the right, or sorry, I will place it to the left to show you that it will be placed automatically to the right in this case, because the left is, there's no space in the left. Sorry, I mean again left. So now I position the tooltip to show on the left, but since the left has no space, it will show automatically to the right. All right. Now I'll put it again to the right. All right. Now this is for flipping. As you can see here, it is done. Not done, sorry. Concerning the recursivity of the function, we have here a small issue. Now we're iterating the whole function, so we're rebuilding the point. We are rebuilding the boundaries here, and also the rectangle here. These, we don't need to rebuild them again. They will stay the same and used by the recursive function. The recursive function only need to be consist with here the positioning and the check here. Plus we'll need to limit the function to only 3 iteration at maximum. So let's do this now. So we'll create another function inside of this function, which will be named recursive. We'll accept a parameter of placement, or more correctly, it required a placement parameter. Now we need to immediately call this function with the current placement parameter, and we need to return it. All right, so this will be our recursive function. Now inside of it, we will need the position object. Next, we need the switch. Then we need here the check. And here we need to return inside of it the PT. Now for the point here, since it is an object that define a point with X and Y, what I will do is create it separately. I will create a constant point which will be equal to a function that return an object. Inside of it there will be the X. I will make it at the beginning as null, the Y as null2. So this way we can detect if it's defined or not. Now I created this object to add a function to it, or a method if you want, reset, which will take a point and it will reset the X and Y to the new point. So this dot X will be equal to P dot X, and this dot Y will be equal to P dot Y. This will allow us to create a cleaner code. So here where I'm defining the point, it will be now a new point object, and this point object will be used as we are using it, which it has the X and Y. But here, instead of, now we can make it constant because we have the reset function, So instead of assigning it a new object, we use the reset, giving it the new object returned by getPoint. Now we call the recursive here, alright, which need only the position. This is reset. Now here is our recursive function, which once it is called, it will determine the x and y, and then check that the point is inside the restrictive rectangle. Now if all is good, it will return pt. Now if not, it will run this line here. So to illustrate this, here is an illustration that I made to show you how this process will work. First, we call this function the recursive function. First time we'll run the recursive function. It will reach this line here, which is another call to itself, which result in pausing the execution of the first function and creating a new stack for another call for the same function. Now the another call will reach also this line, then we'll call another time the function itself. Now this function also is paused at this line, so it will stop here the execution for now, awaiting for the return of this function, same as the previous one that is awaiting the return of this one. And now this one is awaiting the return of the new call, which is in a separate stack now. Now it will keep on doing this forever, which will result in an error. But here in our case, we have a condition, this, so we are not calling it without any condition. So this condition, if was false, in that case, it won't call the recursive function. It continues the execution and return the point. So once it returns the point, this resumes the execution and send the point as a parameter to reset, which will reset our point. Then it will return the point. Once it returns the point, we'll exit the function. So after exiting this function and returning the point, the same for this one, we'll return the point and we'll exit this function. Now we are not in the recursive function, we have exited the recursive function, which return the point. Now we're at the getPoint function, which now return the result of this recursive function, which has returned the point. Now once we return from the getPoint function, we'll exit the getPoint function. All right. So always when you create a recursive call, you should have a condition, and this condition should at a certain time stop the execution and turn after a number of iterations. So make sure the condition is valid for a recursive function. So here in my case, all right, it is working. So there is one iteration. So the user has defined the tooltips to show at the button, but the button, there is no space, so it will show at the top. This is a one iteration, and we exit the recursive function altogether. Now there is one case here that we haven't covered in our solution. Imagine the button has a height of, let's say, 140, some large height, and there's no space on both sides, the button and the top. All right. So what will happen here? The user has specified the tooltip to show at the button. There's no space. Now the application change the position to the top. Again, top, there's no space. It will negate the position. Now it is bottom. So we're here in an endless iteration. So what will happen? We'll get an error. We'll get a stack reach the maximum capacity. So if I try it now, all right, maximum call stack size exceeded. So this is what happens if you have a condition that is not a valid condition for recursive functions. So what we want to do here, if on the second iteration we need to stop the execution, so we need to add a counter to limit this function from iterating endlessly in case where there is no space on both sides. What we need to do is create a counter and count for each iteration. So if there is one iteration, it's okay. Second iteration, it's okay, which negates the position back to the user choice. Once we reach the third iteration, there is no check. There's no place for another iteration. It just return. So to add this check, we'll create a variable here. We name it recurCount, which will be initially to 0. Then in the recursive function, we'll increment this variable each time we do an iteration. And here in the condition where it run an iteration, we'll add another condition on top of it, which checks the recur counter. If it's larger than 2, if it's lesser than 2, or if it's lesser than 2, proceed with the check, else proceed to return the point immediately. Oh, this is lesser than 2. Here, if recur count is lesser than 2, we'll proceed here with the check. Now, if it's larger than 2, we'll skip the check and return the PT, which exit the function without any further iterations. So let's check it in our browser. First, here I have the getting started button, which have a placement button for the tooltip. All right, all is working good. Now, if there is no space at the bottom, it will show at the top. Now, in case the bottom is very large, let's set it height to 140 pixels or even more. All right, and we tighten the width of the windows, so the button now don't have any space from the bottom side or the top side for showing the tooltip. We see that the recursive function doesn't iterate forever and return an error. So here it is stopping at the top. But if we increase the counter to 1 iteration, that way it will favor, if there is no top and bottom available space for the tooltip to be placed, it will favor the position of the user. So now it is showing at the bottom. Next, once we do the boundary restriction, you will see that the tooltip now will be pushed to the top in this specific case. So it will be visible under the getting started button here somewhere, leaving a 15 pixel from the bottom. Now, let's work on this code. For example, here, the sign out is on the far edge. Now, this is not a case of flipping the tooltip. This is a case of pushing the tooltip inside of the allowed boundary. So this will apply also to this case here. After we have tried to solve this situation by flipping the tooltip still is outside of the boundary because both sides have no space. In that case, the restrictive boundary will kick in and push this tooltip inside the window in any case. So let's do it now. Now here, after flipping the point and before returning it, I'll add another check for the restrictive boundary. All right, so here will be the code that will restrict at the end the element. It will push it inside the boundary, whatever the final result was after flipping it. So how we will do this? We will create a function in the PT object, which is called restrict rect. This will restrict the point to a rectangle that we need to send in the parameter. So we'll send the bdys which is our main restriction. So in my point object, here, the point object, I'll add another function, restrict rect. Here we get the rect. Now we'll add a couple of ifs, actually 4. We'll check first for the pt.x. If pt.x is less than the rect.left, in that case we'll set the pt.x to the rect.left. If the pt.x is larger than rect.right, then we'll set the pt.x to rect.r. So here it needs to be else if. This is the horizontal restriction. Now for the vertical, again, if pt.y is lesser than rect.top, then we'll set the pt.y to rect.top. Else, if pt.y is larger than rect.bottom, we'll set the pt.y to rect.bottom. Now, I made here a mistake. The pt, to access the pt inside the function, we'll add this. So now if we check, as you can see, now it break out the centering position of the tooltip against the button in favor of showing the whole tooltip. Alright, this is for the sign out. Now here in our case, the getting started button, which at first tried to solve its problem by flipping it, no success, then it will revert it back to the bottom position. Now after adding the boundaries, if we hover this button, we see that the tooltip now is visually accessible at the end. It hovers the element from the bottom where the user originally wanted to be visible. So this is, in my opinion, the best possible solution for this situation. Now we have our tooltip, whatever happened, always accessible. Now I need to add another option for the tooltip that is specified by the user, is the disabled option. So the user can activate and deactivate the tooltip depend on his situation. For example, here in our menu, we don't want to show the tooltip when the menu is expanded. We only want to show it when the menu is collapsed. Let's add now this option. We'll add another prop to the tooltip, which is disabled. By default will be 0. 0 means it's enabled. So we add then a check here. So this is where we are generating the tooltip and place it in the DOM inside the body. Here we'll check if it's disabled. We won't generate at all the tooltip, so disabled or portal. So if disabled is true, all right, return disabled. But if it's false, then run this component here. The same for the React clone element. We don't need to clone the element if the tooltip is disabled. So we will check for disabled. All right, if disabled is true, we return the children without modifying it. If not, we'll clone the element adding toMouse event on it. So let's test this new option. Here in our nav link where we are creating the tooltip, we can add the disabled option and set it to whether the tooltip is compact or not. Now we have the compact in here in the rest, which we are using here. So we'll add a check to rest.compact. If compact is 1, which means it is compact, we will not disable the tooltip. If compact is 0, which means the navbar is expanded, we want then to disable the tooltip. So if I go to my browser now and check, no tooltip when the navbar is expanded, but if it's collapsed, the tooltip will be activated, which is great. Now we can test also when the tooltip is on scroll. Plus, as you can see now, the tooltip is fixed on the screen. The tooltip still works because it is positioned in relation to the window screen, not the document concerning the height. Next, we need to add a color option for the tooltip. So in our tooltip.js component, we add another prop, which we'll name it BG. Now, since we are not using the props, I can get rid of it. So the BG, we'll need to send it to the style tooltip, which will be used for styling the background color and the color here. Our background color currently is set to transparent black. What we need to do is instead of specifying here directly the code, we need to make a check p.bg. Here we return the p.bg and we'll add to it the RGB. So it must be an RGB. Remember, here in our theme we have followed some format, so each color contain RGB. So the primary has an RGB, the secondary also has an RGB. For example, if we want to use the dark, we need to then add an RGB. Same for the light. So the colors that don't have RGB, we add a default color. So this need to be first in a var dash dash, here it's color dash, the name of the color could be primary, could be secondary, or dark or light. Then we'll add to it here, we'll append to it the RGB, which give us the RGB format of the color. Now in case this color doesn't have an RGB, we can add a default value with CSS for the var function. So the var check, if there's no RGB, then we'll use the black color. Alright, so the var take two parameters. The first one, if it's available as a variable, will be used. If not, the second one will be the default. Now this is for the background color. Now for the text color, use the var dash dash color, and we'll get the color specified by the user, which is in the BG. Then we'll append to it this time the contrast. Alright, the contrast also, following our theme strategy, each color has a contrast. So the contrast is a color that you can use it for text or some elements that are on top of the color. And we'll also add the default, which will be F255, 255, 255, which will be pure white. Now for my global style here, I'll quickly update the dark to add to it the RGB. The same for the light, in case the user want to use dark or light colors. And the dark, I'll make it darker with 444 hexadecimal. Alright, back to our tooltip.js. I think here we are done with the color of the tooltip. So now if I go to my, let's say, header and choose a color with BG using the secondary, for example, color. So this is the button on the header. Now if I go to my application and hover the sign out, it will be blue, but the color still black. Here I forget to add the dash, so it's dash dash color dash secondary dash contrast. So now if I check again, it will be white. Now for the animation, we'll add some transition and some transformation. I have already in my clipboard the properties needed. So here we are adding transition for the transform and opacity property. Then we are adding transition duration of 0.06 second. So it will be very minimal, the animation. The transition timing function is this cubic Bezier, which we are using on our application here in the nav bar. Then we are adding the transition delay, which is specified here by the user. All right, so to let the user specify this delay, we'll add here a prop delay in our tooltip function, and we'll send it to our styled tooltip. So we'll add delay, which will be equal to delay. Now we can use it in our styled component CSS, as we are doing here. So for the delay, we have a condition for the delay. If the tooltip need to be visible, we use the user-defined number for the delay. If not, we'll use a very quick and tiny delay for it to be quickly hidden once the user moves the mouse out of the triggerer. Then we'll transform on the scale. We'll scale the tooltip, so it will have a zoom effect, and we'll control the origin of the transformation with the user provided placement. So if the user place the tooltip at the bottom, the origin of the transformation will be top. That's why we are negating it. All right, now I'm using the BG and the delays props here, but these two are optional. So what I will do here is set some default value for this attribute. So I will add the attr, which will take a function that gets the props as a parameter. Here I'll set the bg to p.bg. If not, or I'll set it to dark. And remember, dark is a color in our theme. It's defined. Next, for the delay, it will be p.delay, or if it's not defined, here we need to return this object. We can wrap it with parentheses, or 0.01, a very small delay which is neglectable but is there. So if we did everything correctly and there's no typo in our code, everything should work as expected. So let us try it. All right, did you see the animation here and here? Now let's try it on the nav bar. All right, did you see how the origin of the animation is on the right of the tooltip? So it zoom in from the right. Now we have reached the end of the tooltip project. Now we have some cleanup to do from our previous video. In our previous video we have worked on the nav bar, and everything is working fine, but there are some small glitches. For example, here, check the arrow button here. So if I now resize my window, as you can see, the arrow is resizing with the flex layout. So the flex is controlling its size. So to force this button to have a fixed height, we need in the nav toggle, instead of setting the height, we'll set the min height. This will force the height always to be 42 and remove the control from the flex layout. So as you can see, it is now always 42. No resizing of the button. Next, if you reduce a little bit the speed of the animation, you can see that here these two links are overflowing the bar slightly. All right, now it is quick, difficult to detect it, but to solve this situation, we can add an overflow hidden for the main wrapper of the bar. This will prevent any element from overflowing the bar. All right, now This also has another impact on our navigation here. As you can see, if I hover outside of the button, the hover still is activated. So this is also one of the problems that will be fixed once we set the overflow hidden for the main nav bar. So if I go to my nav bar here and set the overflow to hidden, alright, now we have solved this problem. And as you can see, our tooltip work as expected, even though we have added overflow hidden to the nav bar. But remember, the tooltip is displayed in the bottom of the page outside of our application container. Alright, so this is the end of our React video tutorial. I hope you enjoy it. If you do, subscribe to my channel for more of this kind of tutorials, and give this video a thumb up, which I very appreciate, and see you hopefully in the next tutorial.